Have you ever thought about whether we're truly alone in the universe or if there's more to our existence than what we see? What if the James Webb Space Telescope finally proves that we live inside a black hole? Join us as we learn more about this groundbreaking news that will make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you might have seen them in sci-fi movies, but the reality is even scarier. According to scientists, they're not just pitch-black holes in space. They're actually massive amounts of matter squeezed into an incredibly small area. Think of a star 10 times more massive than the Sun, all packed into a sphere the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for centuries, ever since they pondered objects in space so massive and dense that they could trap light. The most famous ideas about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a tiny, dense core. If this core's mass is more than 3 times that of the Sun, gravity overwhelms everything else, leading to the formation of a black hole. Detecting black holes is no easy task, since they don't emit any light. However, scientists have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it pulls that matter towards it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can get torn apart, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, emit powerful gamma bursts, and even influence the growth of new stars in some areas while stalling it in others. But where do black holes come from? Picture this. Stars, once magnificent and blazing, meet their ultimate demise in a spectacular explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached their celestial retirement party in a supernova blast. Smaller stars, when they die, transform into something called neutron stars, which are superdense but not dense enough to trap light. However, if a star is about 3 times the mass of our Sun, it collapses under its own gravitational pull, forming a black hole. As these mighty stars collapse, something strange occurs near their surfaces. Time itself starts to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the point of no return for anything falling into a black hole. It's like the star's clock ticks at a different pace compared to ours. Sometimes, when 2 smaller black holes collide, they combine to form an even bigger and scarier black hole. If a black hole teams up with a neutron star, they create a colossal nightmare that defies comprehension. Scientists have been grappling with the scale of these cosmic phenomena for years. Black holes come in 2 sizes, huge and small. There's a sinister mystery surrounding them that we can't seem to unravel. But here's the twist. Small is relative when it comes to black holes. Stellar mass black holes, remnants of massive stars, can be as large as 10 to 24 times the size of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone, an astronomical number of black holes that could swallow anything in their path. But wait, there's more. Supermassive black holes are on the other end of the spectrum. They are millions, if not billions, of times larger than the Sun. They exist at the center of large galaxies, including our very own Milky Way. It's like a gaping dark void that's pulling everything towards it. Renowned physicist Stephen Hawking talked about black holes in his lifetime. His lectures were always insightful, but some of his theories couldn't be confirmed due to a lack of necessary equipment. However, there's hope on the horizon. A single scientific instrument is changing everything, and we're not ready for it. It goes by the name of the James Webb Space Telescope, JWST, and it's here to plunge into the depths of our universe. The JWST is no ordinary telescope. It's an engineering marvel, a testament to the potential of human ambition. Sure, we've launched other space telescopes before, and they've been doing their jobs just fine, but this one is in a class of its own. The JWST makes the Hubble, which has dutifully served us for years, look like a mere speck in the cosmos. The price tag of this astronomical wonder is a whopping $10 billion. Yes, you heard that right. That's enough zeros to make your head spin. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, not to mention the invaluable input from over 300 universities. But let's not forget the risks that come with such a grand undertaking. This isn't a venture for the faint of heart. The JWST is venturing into uncharted territory, pushing the boundaries of what we know and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its minimum mission life expectancy of 10 years. Since its launch, the JWST has made many incredible achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside permanently. During its journey, the telescope successfully unfolded its massive 5-layer sunshield and giant main mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has fine-tuned and calibrated it, the telescope is almost ready to go into full operation. One of the most exciting things about the James Webb Space Telescope was when NASA announced that it had captured its first images of starlight. The first image taken by the telescope was of a star called HD 8446, resulting in a match of 18 scattered bright dots from the star's light captured by the 18 mirror segments located on the primary mirror. NASA later released a new and improved image of HD 8446, in which the 18 unfocused copies of the star were brought together in a deliberate hexagonal formation. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the image stacking process, bringing 18 images on top of each other into one clear view. Thanks to its sophisticated technology, the JWST will help scientists investigate the early stages of the universe after the Big Bang. It will study what happened after the first stars formed, a period known as the epoch of reionization. This era refers to when neutral hydrogen was reionized or made to have an electric charge again by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are very difficult to spot because of the way they interact with their host stars. Its powerful sensors will be able to observe these planets in more depth, including, in some cases, imaging their atmospheres. Understanding the atmospheres and formation conditions for planets could help scientists better predict if certain planets are habitable or not. Apart from studying the assembly of galaxies, scientists study galaxies to see how matter is organized on a gigantic scale. This, in turn, lets us see how the universe evolved. The spiral and elliptical galaxies we see today evolved from different shapes over billions of years. One of the JWST's goals is to look back at the earliest galaxies to better understand that evolution. Scientists are also trying to figure out how we got the variety of galaxies that are visible today and the current ways the galaxies form and assemble. However, most importantly, the James Webb Space Telescope will help us answer the most profound questions of all. Are we alone in the universe? And are we living inside a black hole? The JWST has already been on the hunt. And guess what? It found compounds called polycyclic aromatic hydrocarbons, PAHs, lurking around those gigantic supermassive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are like the goth of the universe. They're everywhere from distant galaxies to comets in our solar system. They're not just fascinating because they could be the building blocks of life, but also because they help astronomers track star formation. When ultraviolet radiation hits these PAHs, they go all flashy and emit infrared light, a sight that can be detected by the JWST's mid-infrared instrument, MIRI. This is usually a sign that there are some hot, young stars hanging around. But wait for the plot twist. A brave astrophysicist, Ismael Garcia Bernard from Oxford University, decided to take a peek at 3 active galaxies known as NGC 652, NGC 731, the spooky famous Stephan's Quintet, and NGC 749. These galaxies are millions of light-years away in the depths of darkness. Now, what Garcia Bernard discovered will make your hair stand on end. In those central regions where the black holes reign supreme, he found an abundance of PAHs. Sounds good, right? Well, here's where it gets chilling. The radiation near those supermassive black holes twisted the PAH's very essence, transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs vanished into oblivion. Imagine being devoured by the darkness itself. But wait, there's a glimmer of hope. The larger PAHs managed to survive because they found shelter within thin, dense, gas-filled clouds. It's like they found their own protective cloak against the horrors of the black hole's wrath. Now, you might wonder why this dark twist matters. Well, you see, it's a bit of an enigma. The transformation of these PAHs into larger versions could mean we're witnessing some kind of cosmic evolution happening at the core of these black holes. Could this be evidence of a galactic womb within the heart of supermassive black holes? Could these places, with their extreme conditions, be where new forms of life are actually being born? The discovery has ignited a flurry of debate among scientists. Could the very core of black holes be the birthplace of new life, the cradle of cosmic evolution? The thought is mind-boggling, to say the least, but it also raises some important questions. Could we be living inside a black hole ourselves? Could our universe be one giant, contained system within the immense gravity of a black hole? If that's the case, what does it mean for the future of humanity and our place in the cosmos? These are the kinds of questions the James Webb Space Telescope will continue to explore as it plunges deeper into the mysteries of our universe. The possibilities are endless, and we're just scratching the surface. What we discover next might make us rethink everything we thought we knew about space, time, and even our own existence. As the James Webb Space Telescope continues to unravel the mysteries of the universe, its mission goes beyond merely observing distant stars or cataloging galaxies. One of the more intriguing aspects of the JWST's potential is its ability to explore the unseen, uncovering phenomena that have previously eluded even the most advanced observatories. This includes the study of dark matter, an invisible substance that accounts for approximately 27% of the universe's mass and is critical to our understanding of cosmic structure. While dark matter cannot be directly observed because it doesn't emit, absorb, or reflect light, scientists believe that its presence can be inferred through its gravitational effects on visible matter. With its superior resolution and infrared capabilities, the JWST is uniquely equipped to study these effects in unprecedented detail. Additionally, the JWST is expected to shed light on the formation of galaxies in the very early universe, potentially tracing their origins to a time only a few hundred million years after the Big Bang. By looking so far back in time, the telescope can observe the first galaxies to form and study how they evolved over the eons. This could help astronomers answer a critical question. How did the first stars and galaxies emerge from the primordial soup of hydrogen and helium, the only elements present shortly after the Big Bang? Understanding these processes will not only help clarify the history of the universe, but may also reveal clues about the conditions required for life to exist elsewhere. The search for habitable planets, or Goldilocks worlds, remains one of the JWST's most anticipated missions. The telescope's instruments are capable of detecting the faintest hints of life-supporting atmospheres around distant exoplanets, including the potential for oxygen, methane, and water vapor. In fact, astronomers are particularly interested in identifying planets within the habitable zone of their parent stars, the region where conditions are just right for liquid water to exist on the surface. This is crucial because water is considered one of the essential ingredients for life as we know it. With the ability to analyze the atmospheres of exoplanets in greater detail, the JWST could help scientists identify planets that may harbor the building blocks of life, or even signs of life itself. But the JWST's contributions may not be limited to just our search for life in the cosmos. Its discoveries could also influence the way we look at life here on Earth. For example, studying the diverse chemical environments in far-off galaxies could provide insight into how life began on our planet. Researchers have long speculated about whether certain chemical processes, such as those involving carbon and nitrogen, could have taken place in the early Earth's atmosphere, leading to the rise of organic molecules and eventually life. The JWST could provide new data that might suggest similar processes happening on other planets, offering new perspectives on the origins of life in the universe. One fascinating possibility is that the JWST could help us understand the relationship between black holes and the growth of galaxies. While scientists have long known that supermassive black holes reside at the centers of most galaxies, the exact mechanism by which these black holes influence their host galaxies is still a subject of much debate. Some researchers believe that the intense gravitational forces of supermassive black holes could help regulate star formation in galaxies, either promoting or suppressing the process depending on the specific conditions. As the JWST observes distant galaxies, it may provide new evidence that will allow scientists to better understand how black holes interact with their environments. The possibility of discovering new phenomena is also an exciting part of the JWST's mission. While the telescope is designed with specific goals in mind, such as studying the early universe, the hunt for exoplanets, and the investigation of black holes, it is likely to uncover things no one expected. Much like its predecessor, the Hubble Space Telescope, the JWST may stumble upon completely new cosmic phenomena that change our understanding of the universe. Whether it's the discovery of a previously unknown type of galaxy or the detection of strange cosmic structures, the JWST's ability to explore the universe in ways no other telescope has before will likely lead to groundbreaking revelations. Perhaps most remarkably, the James Webb Space Telescope serves as a symbol of human perseverance, curiosity, and ingenuity. Its development, launch, and operation are a testament to what humanity can achieve when nations, institutions, and scientists come together with a shared vision. As the JWST begins its work, the questions it will answer, and the new questions it will raise, will continue to inspire generations of scientists, philosophers, and dreamers, encouraging us to look up at the night sky with awe and wonder.